Assalamualaikum warahmatullahi wabarakatuh. I am Ishad Rus bin Sharus, EWEC 00552, and I'm from Group Elite Squadron or ES. So this is my reflection for all the tasks and what I learned from each task. Okay, so starting from first task, task one, we started by making a floor plan of each floor. So what I learned from this task is that before you need to do a building or like development, we need to start with a plan. So what I decided with the research of my friends is that um, we need to put more commonly visited labs like the general lab on the computer security lab on the lower floors so that if people walk by they can just like check don't need to walk around too much. But if it's on the second floor, it's IoT lab, network lab, and then the video conference where not many people go around, so it doesn't feel like, that busy. So that's why those are on the second floor. Right. Next, what I learned from task two. So task two is where we do Q&A. So what I learned is that we need to research first, so like we need to try and see what is the problem and what is the solution. So let's say our problem is that what is the best connection, 3G, 4G, or should we try 5G, because 5G isn't stable yet, but 4G is stable and it might be faster because it's stable. So that's how we start researching, and then we use Google Scholars to find relevant papers on the topic. And then we also decided that using Unify might be the best networking service on, I mean, like internet service provider in Malaysia. So that's the things that I learned in task two. Now task three is one of the parts where we need to shop for devices. So in this part, I learned that there's actually quite a lot of budget needed to start developing a building, like connecting network device in the building. Because at first I thought it was less than 100,000, but it actually comes for our project. It actually comes to 310,000 ringgits. So that's something that opened my eyes on, like, it takes a bit to start developing those kinds of things. Right. Next, in task four, one of my favorite tasks is that we need to do a networking sort of like wiring diagram instead of a schematic diagram. So this is one I drew, and then I color coded each labs, and then I connected wires. So we did more research on like what's the perfect position to place a router. We came to a conclusion that a router needs to be placed higher if possible. So we decided on the second floor, and then close to a window or where a place where it's less obstructive. So we decided to put it on the left wall here because it's closest to a window. And then uh, if you like continue the research, it says that for home devices, a router actually usually is commonly placed inside the middle of the house, which is a bit different from before. It says that you need to put close to a window. Why this one says in the middle of the house? Because from that one, it says that, oh, if you put near the center of your house, it can distribute the networks better. That you can get a more like stable connection everywhere throughout your house, compared to like if you put it on the left side of your house, you can get it on your right side of the house. So from that sense, we take that sort of logic. So even though our router is placed near the window, we place the access point in the middle of the floor. So that way, the router can pass a wired connection to the computers and all the like students and teachers computer in the floor, but the access point is in the middle so that everyone can still get a Wi-Fi connection if they want. Right. So that is what I learned for task four. Now the task, task number five is the IP. So for the IP address, we applied the logic of signed bits, signed integers. So like if you use a signed integer, the first bit tells you if the number is positive or negative. Like 1,000 is 1,000 might be a negative number, and 0,000 is a positive number. So we applied that logic, and then we took 3 bits, since we need 8 areas. We took 3 bits and then used those first 3 bits remaining from the one that we calculated. So it says 23, so we can use 9 at the back. And then from that 9, we took 3 and then use those 3 to determine what lab it is in. So if the first 3 bits is 000, that's the general purpose, the one at the bottom floor. And then 001 is computer security. And then the rest is for like on the right side, like follow the columns on the left. So it's different areas for different bits. Okay. And then the remaining 6 is where we actually use the IP. So we can identify up to 2 to the power of 6 amount of devices. So that's about 64, I believe. So we can use up to 64 connections per area. So like one lab can have 64 connections. So like 30 wired to a computer and one from the teacher, and then maybe some extras we can use. So that's how we came to this number, the IP. So this is like the number here shows you what the IPs can start with until the next one, which is says like 129.0. So that means that this can be up to 192 to 255. So the number before the indicator one. So that is what I learned from task number 5. All right. Since there's the last task, I'll end this here. Thank you.